So as you said, my name is Michael Brewer. I'm a senior manager, high performance research computing at St. Jude Children's Research Hospital. It's kind of a mouthful, but I'm going to do a quick introduction of myself and then spend quite a bit of time talking about what St. Jude is and what our mission is. A little bit of time talking about past trends, growth, and future focus areas within this kind of HPC space for us. And if you have any questions, just let me know and we'll do that. I'm not going to belabor this, but this is kind of the background. I've been at St. Jude now for about 7 years. Before that in industry, before that at the Department of Energy, doing software and high performance computing. Interests are artificial intelligence, high performance computing primarily right now. Prior to that, my background was in mesh generation, finite elements, those types of things with the Department of Energy. St. Jude is really best described by looking at our mission, which is to advance cures and means of prevention for pediatric catastrophic diseases. So that's why the institution exists. The founding quote from Danny Thomas, if you're familiar with Danny Thomas, in the 60s was, "No child should die in the dawn of life." That I think is a mission we can all get behind. It's a statement we can all agree with. And so it's a really amazing organization. And as a children's research hospital, we don't really do product endorsements, but we do have a very close collaboration with DDN. They are a provider of a lot of our equipment. We work with them closely to make sure we're getting the most out of it, to make sure we're meeting the mission of St. Jude. So that's what we'll kind of talk about here today. This kind of re-highlights the goals of what St. Jude is trying to do, but it's advancing through research. So the second line here, St. Jude is in the business of knowledge discovery. That is what St. Jude is trying to do. And then I want to highlight a little bit this next section, which is global. So the real mission here is to save lives, to make the lives of children better. And kind of the best place, the biggest gains can be had globally. So reaching out outside of Memphis, outside of the US, where survivalship is at a much lower rate than what we see in the US. Historic moments, I'm not going to go through all of this, but these are some of the accomplishments that have happened tied to St. Jude. And the real kind of flagship example here is acute lymphoblastic leukemia, ALL for short, which was one of the first diseases tackled at St. Jude. When the institution was created, ALL was at a very low survivalship. It was actually considered inhumane to try to treat this disease because the treatment was often ineffective and worse than the disease as far as quality of life. That changed with the advent of Dr. Pinkel. Some other people were working on this disease, and survivalship went up to over 80% within a few years. So we went from a disease that couldn't be treated to a disease with an 80% survivalship with these treatments. So really just paradigm shifting kind of advancements in these. I mentioned, so if we look down here in 2006, the US survivalship is now at 94%, which is, we're going essentially from 0 to 94%, which is just, amazing. And in 2010, there were several projects launched, and one of them is the St. Jude Global Initiative, which we just talked about, and that is trying to get these cures and means of prevention out at a broader community. Online, we've got a strategic plan. This is for a 6 or 7 year period. We're going to extend it a little bit, and then we'll create a new strategic plan for the next set of years. And I just wanted to highlight, in the past several weeks, right, these are some of the press releases that have come out. And the thing to kind of note here is a lot of these are now becoming data-driven types of announcements. So, for example, this top one, AlphaSync, this is tied to AlphaFold. It's a high-performance computing application that keeps databases up to date using this type of technology. But it's an ambitious plan. That's the goal here, is FY27, there was a lot of growth, and we'll talk about that a little bit specifically. My group specifically is the Research Information Services. We're spread across several different disciplines. I'm in the high performance research computing group. We also have people that work with the laboratories. So go out, get connectivity from the instruments, which are the key part now of the first part of the research. Instruments to storage to the HPC so that we can utilize everything effectively. There's cloud, there's application support and data governance. All these things tie together to give the researchers an effective environment to work in. So I'm not going to go into a ton of detail here, but some of the things that have happened over the past 4 years, we have doubled our storage utilization in the past 4 years. This is not specific to St. Jude. If you talk to a lot of people on this floor, they're going to tell you the same thing. The growth of the data has been nearly exponential, right? And we're at 100 petabytes today. That is a significant infrastructure to keep running. Some other takeaways: our genomics data historically has been the primary data source within our systems, but the fastest growing really is the bioimage community. So we've got cryo-EM, we've got a lot of light microscopy coming online, and whereas 4 years ago it was 12% of our research storage, now it's 28%, and that gap is closing between bioimage, like the microscopies of the world, to genomics. Genomics is still growing. It's not like genomics has stopped. Bioimage is growing faster. Other trends here are that we have more and more different regulations, different utilization patterns that we're having to address, and we can't just keep growing monolithic systems. And so what we've done over the past few years is we've increased from 3 systems to 8 to address all of these different regulations to make sure we're meeting all of the needs without one huge monolithic potentially point of failure, right? We want to be as resilient as possible. We've added a second data center in a co-location. We're all aware of cyber activity. We're all aware of potential disasters that can happen. We've got a second data center, and kind of the key takeaway from our second data center is it's got a second copy of almost all of our data there live. So if one site goes down, we've got a second site that can come up and take the bulk of the load. And both are active, but they are asynchronously replicated. I won't talk about it a lot. Everybody on the floor is going to be talking about artificial intelligence, but the data access patterns that come with that are significantly different at times than some of the other access patterns. And the real thing that's changed over the past 4 years, like I said, is that initiative that we had to grow the institution, and a lot of new departments and research organizations are coming out of that. The Office of Data Science, cryo, electron microscopy and tomography, the Department of Imaging Sciences, all of these are really data-heavy producers that we have to account for in the growth plans. And then the next 4 years. I mentioned we doubled in size as far as the utilization over the past 4 years. We expect that doubling to happen again over the next 4. And this is a trend that at some point we have to get under control to be able to sustain long term. Because of that, we are looking at improved tiering. So instead of one big bucket of storage, we are going to need multiple purpose-driven storage systems to highlight what we've got. The sharing and collaboration, we are doing a global initiative. So that entails sharing with people globally, locally, within the institution, across the world. That is the next area of improvement that we are planning to do. More tools, better tools, more seamless sharing. And I've got hybrid and edge over here. By more seamless sharing, what we really need is a unified environment that people don't have to know all the details of specifics on what they're doing under the covers. We've also got interest in quantum computing. Several of the researchers are working on algorithms that are quantum specific, have quantum advantage. And so we are looking at how that technology is going to integrate with our current system. Now, I will note that the improved tiering and the artificial intelligence patterns are a little bit at odds. So we want to be able to meet the artificial intelligence use case, which is going to entail reaching out to all the data that you have to take advantage of it. And when you do that, you need it to be accessible So some of the older techniques of pushing everything down the tape, maybe just keeping metadata, may not work in this paradigm, and we'll have to have a more advanced technique for tiering at a cost-effective level while still meeting the needs of the artificial intelligence community.